And for our last but certainly not least presentation today, I'd like to introduce Christian Schroeder, Chief Product Owner at Siemens, as well as Veronica Lauster, Partner Manager from Siemens. They'll be presenting on the topic of mastering OT cybersecurity and overcoming vulnerability challenges. Over to you, Christian and Veronica.
Thank you.
Lauren.
So my name is Veronica, and I'm the partner manager, as Lauren has already said, at Siemens. And together with my colleague Christian, we want to spend the next minutes to talk about cybersecurity on the shop floor. So this may be the last session of today, but we have something really exciting for you. So let's start with a simple truth, which is that today everything is connected, from our smartphones to industrial control systems. Connectivity is everywhere. And this connectivity brings incredible benefits, but it also introduces potential cyber risks. And most companies are pretty good at securing their IT systems. They have firewalls, antivirus software, regular security audits, and so on. But what about OT, operational technology? How secure is the OT environment? So operational technology includes the hardware and software on the shop floor, which is controlling and monitoring machines in the manufacturing systems. Now here's the challenge. OT systems were traditionally isolated from IT networks, so manufacturers mainly had to focus on securing their IT. But with the rise of digitalization and the Internet of Things, these systems are becoming more and more interconnected, and also given the high complexity of OT, the question is, how can you assess the threats to your OT environment and protect your assets accordingly? And that's what we're here to explore today. We'll discuss the unique challenges of OT security and how they are typically solved today. And then we introduce you to a more efficient and automated solution, which we have developed and also implemented in one of our Siemens factories. Now let's take a closer look at the shop floor. There's a variety of devices which are integrated into machines, conveyor belts, and other equipment. And these devices include, for example, PLCs, drives, switches, and other components. And we call them OT assets. And their primary role is to ensure that the production runs smoothly and efficiently. Yeah, but who's responsible for keeping everything in check? So let me introduce you to our persona. We call him OT Otto. So OT Otto is an industrial administrator. That means his job is to manage all the OT assets that are connected to the manufacturing network and ensure that operations on the shop floor are secure. So essentially, his main goal is to prevent downtime and keep the production line running without any interruptions. But there have been some developments that are making his job more challenging. So what are those developments? So what's changed in the past? So firstly, 75% of companies experience a cyber attack at least once a year. 32% of those attacks target both the IT and the OT systems. And 70% of all ransomware attacks target the factory, the production. And on average, an outage takes 24 days after a successful cyber attack to be resolved. So do you have any idea about how much 1 second of production outage costs on average? Perhaps you have some kind of estimate or guess. Is it 50, 100, or 10 euros per second. Well, it's actually 200 euros per second in the manufacturing industry globally. So this adds up really quick. So for a 24/7 production, one day only is 20 million that it costs you. So that's quite a lot, of course, and not to mention the reputational loss that you might have. So that's why governments around the world are recognizing the critical importance of securing the operational technology, and they're taking action by introducing more regulation. So for example, one is the NIS2 directive in the European Union. And for OT Otto, this means that he has to ensure that his organization complies with these new regulations. For example, he has to have transparency on his risk situation, be proactive in identifying and mitigating risks, and have robust incident response plans in place. And if he fails to comply, or the company fails to comply, then this can result in significant fines and penalties, even for the CEOs. So as a consequence, OT Otto's role is becoming more and more crucial than ever, but also more difficult. Now let's have a look at his specific tasks and how he solves them today. His first task is OT asset management. So he has to know which assets are on the shop floor that he's responsible for. So he needs to discover them. He needs to identify what type of asset is it, and which firmware does it have, how old is it maybe, and their status as well. So is it faulty, is it running, what's happening? He needs to know that independent of the vendors and the asset types, because believe it or not, most customers have not only Siemens assets in their factories, they have different vendors. And then he has to keep the firmware of the assets also up to date. So that's his first task. How does he do that? Well, today he often does that manually. So he kind of keeps, for example, an Excel sheet, or uses some other tools, but it's basically on site, it's time consuming. There's a lot of errors, of course, because there's no automation, and also there's no automatic update to changes in the inventory. So it has to do that over and over again. The second task that he has is vulnerability management. So he has to analyze the so-called security advisories that the vendors are publishing. I'll show an example on the next slide. Evaluate their vulnerability risk on his specific factory, his situation, and then prioritize which mitigation measures does he have to perform first, what is maybe not so important. So today, this is what it looks like. So this is one example for a security advisory, which Siemens, for example, publishes every 2 weeks. And more over the years, each year, the number of vulnerability rises. And so today he prints these, and now he has to figure out which assets did I actually buy, like which am I using in my facility. He has to mark them. Then he has to know which he's actually using and which firmware they have, and whether they're affected by this specific security advisory. And you can see there's, in this example, there's 14 pages. So that's a lot of work, and it takes a lot of time, and it's also error prone. So there can be false positives, or even worse, false negative decisions, which means that you don't update an asset even though you should. So a vulnerability can remain unfixed, which can be exploited by hackers, for example. And also the risk evaluation is pretty much based on his individual judgment and expertise. Then once he knows what he needs to do, which measures he has to take, he needs to define these tasks and schedule them, and then also orchestrate the execution of the tasks. So again, today, this is often done manually or via email. So it's time consuming, you lose the overview, there's no consolidation of a task per asset, no tracking, escalation, documentation. So overall, his 3 tasks that he does step by step to reach his goal of secure operations are OT asset management, vulnerability management, and task management, which are mainly, let's say, fulfilled manually. Of course, it depends on the customer situation, which takes a lot of time, lots of errors, there's no overview, and it takes also his know-how. So, of course, we asked ourselves the question, how can this be done more efficiently and effectively? What can Siemens do to help customers with this? And with this, I'm handing over to Christian, shows the solution.
I mean, when I hear this again, how Otto has to do this currently, I feel this strong urge to help him. And I hope you do too. So that is why we actually looked at how can we make the most out of it. And as you may all know, what we've heard from Veronica is what we do not want to do. And also in this webcast with AWS is do stuff manually. Automation is key in making our lives easier. And this is exactly what we did for and with OT Auto. So the first step, which Veronica talked about, the sneaker stuff, he has to go down to the shop floor, discover the assets. This is what we did automatically with a tool we call Industrial Asset Hub from Siemens. This one is a hybrid solution and it does the jobs of discover and identify, meaning we deploy sensors in the field on the shop floor on our Siemens Industrial Edge platform. These sensors then automatically scan the network for the assets and then upload those assets onto the Industrial Asset Hub platform running on AWS. So we have the asset management system there where we have constant scanning and we can also tunnel through to the networks on the shop floor, to the assets on the shop floor. After that, of course, it was the next step we have seen. So currently, Otto has to go through all those pages and match all those assets to the vulnerabilities from the advisories. And this we also automated. And we call these steps, of course, the matching and the prioritization step. Because after the matching, what he has to do currently manually as well is the prioritization. What do I have to fix first to keep my production up and running and out of harm? And this is done with a second tool, the SINEC Security Guard. This has the main job to match and to prioritize, meaning we get the assets, of course, over an API from AWS to Siemens SINEC Security Guard, that we have those assets, and then we take the public available advisory resources from the vendors and match these assets with the advisories. And out of this, we get all the vulnerabilities listed. And then we take in regard the custom criticality of the production process, and then we prioritize for the customer, for Otto, these vulnerabilities. And of course, what's missing? We scrap the manual task board and we go to a solution which we all know because we go to ServiceNow. If customers have the IT infrastructure, we then make an API connection to ServiceNow and we can do all the tasks which somebody has done or Auto has done in SINEC Security Guard. We can forward them to ServiceNow so that they can be holistically handled there and managed there. If customers do not have ServiceNow yet, they can also use the internal task management of SINEC Security Guard for the steps we call engage and orchestrate. So we have this whole holistic automated solution running on AWS. And to show you that this is not only for the future, but it's already present, we have done this and are currently doing this on our Siemens own site in Bad Neustadt. It's a Siemens factory there, where we integrate all these three solutions into our workflow to make our shop floor more secure. And now you're wondering, okay, it's nice to hear, but how does that look in detail? Let us show you. So, as I said, we have the shop floor on premise with all the assets. So we go there, we deploy the industrial asset hub scanners there on our industrial edge management platform. And when they are installed, what we do afterwards is we upload those assets into the cloud. So they are sent upwards into the AWS cloud, are orchestrated there, managed there. And as I've said, if needed, we can even do a remote tunnel access to the assets directly to look if something's not going on. Afterwards, of course, we want to have a holistic picture. We send these assets to the ServiceNow platform, to the ServiceNow CMDB, so that they are there, so that we do not only have the IT assets, but also know the OT assets in one place, so that everybody can take a look at and see, okay, I have a holistic picture of my whole factory. And afterwards, we also send them to SINEC Security Guard to do their vulnerability management, because what we do not want to have is open vulnerabilities on my shop floor, which can be attacked. And after we have defined the mitigation measures in SINEC Security Guard, we send them to ServiceNow so that the workflow can be started. The administrator can tell, okay, who does the job and when is the job going to be done. And afterwards, when they have finished, for example, the update of the firmware, or they have closed some important ports, because as we all know, in a running production process, you can't always update a firmware straight away for a PLCX, for example. So also these status gets done, and then they are going to send back to SINEC Security Guard so that we can close those vulnerabilities. And of course, what is the big advantage here for our customers, for the factory? I mean, I don't have to tell you that normally when we switch from the on-premise solutions to the SaaS solution, what we currently always have is, especially with AWS, we have written all those applications as a serverless design. And this means we are really lean when it comes to operational costs. Also, it's cool for our factory that there's no hosting on site required. And also, we do updates on the fly, meaning customer wants some new features, we develop it, and the next day they are there. And also, pretty nice for us on the developing part of the software is we have ready for use telemetry and usage data at hand that we can see, okay, which features are used heavily by our customers and which are used rarely, so that we can focus our resources on these features. And when I'm talking about resources, it's also very nice that we can easily scale, meaning this is the first factory, but of course, Siemens has more than one factory, and these factories also have more than one asset. They have more production lines. So we can easily scale up from 100 to thousands of assets and from one to multiple factories globally. And this without no effort, because in AWS, you all know it well, scaling is done easily. But after all this talk, most likely you're now eager to see the stuff live in action. And that's another cool part of a cloud solution. What I can do now, I can immediately show you how this works. So let me take over the screen share in a second. There we go. So going to SINEC Security Guard, because this is the center, I would say, where stuff comes in, stuff comes out. And we can see here, this is my tenant, and this one I have connected to the industrial asset hub, meaning this is where I get my asset from. You can see here my inventory, exemplary of our production line, because as you may well have guessed, out of privacy reasons, we cannot show you the real inventory of our factory. So this is an exemplary inventory standing for the factory Bad Neustadt with all the assets here. And then what OT Auto can immediately do, he can see, okay, how many vulnerabilities do I have which affect my assets? So he goes into the threat focus, he does the sorting by CVSS base score, and he sees, okay, I have some pretty heavy hitters here with the CVSS score from 9.8. What I've said to you, I told you, this is not everything we do. We're not only doing the matching process, we're also doing the prioritization. So where's this? What Otto would have to do is to give us the layout of the factory. So this is we're doing with zone management. So Otto would go inside here, create a zone. Maybe I pick the assembly line because this is very critical for a factory. Little typo here. And then I can define business criticality and the exposure of this line for my factory, for my production process. In my case, the assembly line is the heart and soul. So business criticality would be pretty disastrous, and the exposure, unfortunately, is also very high. Afterwards, I can define an IP range where we put all the assets inside, but for the example here, I just pick a single asset like the PLC. It's just the assembly production, and then I pick next and create, and the zone is created, and the PLC is inside. And when I now go back to the threat focus, I see here if I sort by risk, that all of a sudden other vulnerabilities are my highest priority, not the 9.8 anymore, because we have changed the environment. We have told the software what is the most critical asset, what is the most critical zone, and then we adapt these two values, business criticality and exposure, combine it with the CVSS vector, and create the unique risk evaluation for OT Auto without any special knowledge. Then, of course, afterwards, what he still has to do, define mitigation measures. And for this, what he's going to do, go into this zone with the PLC. He sees there's one affected asset because there's only one inside. He sees it has 15 open threads, 15 vulnerabilities. He goes into the threads and task menu, and then he can see, okay, which open vulnerabilities does this PLC have, and what are the fixes? So in this case, I would select a firmware update. If this is not possible, I can also say, okay, until I have the next maintenance window, please just shut down the web server if possible, because this mitigates also this vulnerability. And if the web server was never enabled, I can also tell the software, this is obsolete by implementation. We never had a web server, and this is already done. But back to a real vulnerability which cannot be mitigated by obsolete because it's there. So let's make the firmware update link for the next maintenance window. Let's create the firmware update task. And then I have connected this also to ServiceNow. OT Auto just presses the button here, publish to ServiceNow. Of course, it's collected by ServiceNow, which we tell the customer here. And then afterwards, ServiceNow collects all my open tasks and display it here in my ServiceNow overview. And the cool part is the operator in ServiceNow can see exactly where these coming from. So if I switch to my 47 records I've gotten from SINEC Security Guard as well, and I select one of these assets here, ServiceNow will show me where this came from. So I click inside, and it tells me immediately what's the source of this item, and I see here Siemens SINEC Security Guard. Cool. I got it here, and I can start my workflow. And what's even better, we also make this whole solution scalable. So if you don't want to interrupt your shop floor with the scanning from Industrial Asset Hub, and you don't have ServiceNow right away, you can always start in the middle with SINEC Security Guard because we also have an integration of the simplest form to get your assets into the AWS cloud. And this is, I switched to another tenant here, just via a simple CSV upload. So we have a little template here. You just collect the assets in the way you have always done with SINEC Security, and then you upload the CSV file so that you at least have a current overview of your risk status of the factory. And then you can gradually expand. Either you go the Industrial Asset Hub way first or the ServiceNow way. It's up to you. But this is totally flexible, totally modular. So this is it. Coming back to one more thing. If I go back to the presentation, what's missing from our side? We have shown you the integration with another Siemens tool, Industrial Asset Hub and SINEC Security Guard. And we have also shown you how we work with ServiceNow. But what we are looking for, in addition to this, is use cases with the AWS Security Hub and Lake. So if you have any idea how we can combine those powerful tools and create some customer value out of it and solve real customer problems, it's our call to action now to you. Because for this, we do need your help. So please get in touch if you have any idea how we can push our solutions forward here. And with this, I would give the word to Lauren for the Q&A session.
Great. Thank you so much, Christian, Veronica. Much appreciated. Contact up there on the screen. Perfect.
And I forgot, if you are around, go to Hanover Fair and visit us in real life. Because what's even better than a virtual presentation, making real life connections. Sorry for this.
Agreed. Please, for the folks in the audience, there are a couple extra questions in the WebEx poll for this presentation. So please take a moment there and fill those out. It looks like we have a couple of questions here in the Q&A. So Christian and Veronica, the first one that I see from Sabarna here is, does it cover all kinds of network segmentation and all kinds of protocols? And the second part of that is, it's similar to Microsoft Defender.
So I would say the first part is regarding the Industrial Asset Hub, because this does the collection of the assets in the field, and we have different scanners. So what you would have to do for every network segmentation to scan inside this network, you would have to deploy a scanner there onto either a virtual edge device or a real industrial edge device, a hardware device, and then select the scanning application which you need. We cover also, for example, like the Ethernet IP scanning solution, so that you can scan Rockwell networks, for example, and find out those assets. So depending on which protocol you're talking, you just deploy the right scanning mechanism there, and then you're good to go. And of course, if you do not support something currently, give us a shout out and we develop it as quickly as possible. For the Defender part, I mean, if you talk about vulnerability management, I would say it's kind of similar. Of course, as you say, the devil lies in the detail, and you would have to take a closer look about the requirements which you need to have to tell you where we can shine.
Good.
So,
there was a follow-up question as well. So the question is, how do the updates get pushed to PLCs or drives when the assets are in running condition? Does it wait for break time, or does it need to be done manually only?
normally we do this manually. We are trying to implement a mechanism. What we can do is we can make and establish a connectivity to the asset, but we don't roll out patches on an automatic way currently, because in the as you can imagine, in the OT environment, rolling out a patch or a firmware update automatically currently is a big risk. We still plan on automatism anyway. So what we plan to do is like bulk actions in SINEC Security Guard and scheduled firmware update, but this is a near future topic because currently it's too risky to define anything, any firmware update in a running production process, because this could really harm the production.
Thank you. Two more quick questions here. I know we have a couple minutes left. The last one from Subarna was, does the solution cover other manufacturers' equipment as well?
Yes. We're going to give you the second sneak peek at the Hanover Fair, but maybe I do a quick glance because we've shown this in the SPS Fair as well. We are going to release vulnerability feed feature, meaning that you as a customer can implement any feed from any vendor, and this gets covered from the vulnerability side. For the industrial asset hop, of course, they have the different scanning mechanisms for different vendors. So we can say, we don't have the full support yet, but it comes end of April, latest end of June for the holistic approach with all three tools.
Great, it's exciting. Final question we have is from Rich. Rich asks, what is the success rate of identifying the make, model, firmware of your IoT devices? He says often limited information can be gathered with a scan.
I've seen an expert here. Yes, you're correct. It depends about the vendor, the asset, and the scanning mechanism you're using. So currently what we're doing is like the non-intrusive passive listening, passive scanning. And of course, this gets you sometimes less information because you're not nudging the asset enough, so to say, to get all out of it. But if this is not sufficient for you, we also have solution and ways of actively probing, actively scanning assets during a maintenance phase, and also during tools which don't do that invasive during the production phase to get the most out of the asset. So we have different scanning solutions, and depending on the vendors and the assets you have, we would choose the fitting one to get most out of the asset, the most information out of it. We have multiple tools in our tool set for this.
Great. Okay, with that, thank you so much, Christian, Veronica, for your time today.